So today we'll be starting with functions. Like from today, we'll start the actual modularity and object-oriented Python concepts. Okay, so just pay close attention. Okay, what is a function? So a function is nothing but a group of statements or a block of code. Okay, so it's a group of statements or block of code which will perform a single task or related tasks, a task or two. Okay. So if you see, we have two types of functions. One is built-in functions and one is user-defined functions. So for built-in functions, you might have came across many built-in functions as of now, like print, input, range, length. So these are the functions which were readily available in the Python. The creators have wrote the logic which will perform particular task, and we are just invoking the function. We are just calling the function. Uh, if you see this print, if you go to the Python internals and find this print of program, so it will contain all the code which was required to print the output which we have given to the console. Okay. And second is user defined functions. These are the actual functions which we'll be creating. Okay, going forward. So user defined functions are the functions which are created by user to perform custom tasks. Maybe anything. Okay. So, user-defined functions, users create these functions on the go while doing programming, and these will be performing custom tasks based on the requirement. Okay. These are kind of exactly functions like built-in functions. Once the function is created and it is available in our project, we can use them as a built-in function itself. So we'll be covering more in the packages and libraries as well, how we can kind of use these user-created functions as built-in functions. Okay. So now if you observe the syntax over here, this is the basic syntax which we are using for creating a function. Okay. So this def is the keyword which will indicate interpreter that this is the function. Okay. We'll use this def keyword for creating a function. Okay. And then this is the name. We need to name a function, and it can be any name based on our requirement. Let's say we are preparing like writing one function which will return us the calculator outputs. Okay. All the arithmetic outputs. So we can name it as a defined calculator, and this will be the arguments. Okay. So a function can contain arguments or cannot contain. We can also define function without arguments. If you are not expecting any input to the function, then you can directly give this empty brackets. So just remember this parentheses are must for a function definition. Okay. And all the arguments are nothing but the values which were passed to the function. Okay. We'll come to know how we'll be using those arguments in the coming slides. And this function body is the group of statements which will be performing the respective task. Okay. In case of this calculator function, we'll be writing code which will take two numbers and it will perform a plus b, a minus b, a into b, and so on. So all these blocks of code will be coming in this function body. And just observe this indentation. Okay. All the code which is written in the function that should be properly indented. Should be one indent inside this diff keyword. Okay. And then this is written. So if we are expecting a result like from function, and if we need to take the output of function and assign it to some other variable, which we'll be using in the other functions or other parts of code, then we can return this. Okay, we can return this output. This is again optional. Okay, even without return value, will be kind of function will be working. But most of the times we should follow this practice of returning the value from function. Okay. And then what are the benefits of functions? So far we have seen many codes. Okay, many programs which has performed some task, right? So let's say we have this calculator function, and it is like it expects different, like at different points of time we need to perform different operations like multiplication, subtraction, addition sort of things. So in that case, instead of writing the code again and again in the program, we can just define the function, and we can just pass parameters which were required at several places. So the first benefit is reusability. We can reuse the function any number of times, any in any files in any project. Like we can also reuse the function written in one file in other file as well without repeating that. Okay. Second is modularity. So let's say we have one large program. We don't have any function defined. We have only program written in a large chunk of code. Okay, code. Let's say we have around 20,000 lines of code. Those are the actual sizes of the production backend code base. Okay. So if you have that 20,000 lines of code, and in like while doing this development, in between we have got some new requirement. Let's say we have some functionality, and we have got a request to enhance the functionality, to modify the functionality and add new enhancement. So if we have single piece of code which is of 20,000 lines, it will be almost impossible to find where exactly that function is present, that particular code lines are present, and to update them. And for testing, we need to run all the 20,000 lines. We need to run end-to-end testing so that to make sure that the changes which we have done are working properly. Okay, just a second. Yours. So this is where this modularity comes in. Okay. So in such case, what we can do, we can divide these 20,000 lines of code into different functionalities. Let's say we have one application which will provide us the journey plan. Okay. Let's say we are similar to Google Maps. Okay. We need to find like build an application which will provide us a journey plan. So instead of writing everything from starting home to reaching office, we can divide it into different modules. Okay. Initially, we can write a function which will calculate the time of the day. So based on the time of the day, we can plan the journey, right? And we can write one more function which will provide us the week of the day. And we can write one more function. Like if there are any, it will ask inputs and identify if there are any stops in between. And there will be one more function which will be used for taking different routes, which route we are planning to take from source to destination. So we can have such small functions to perform each task. Let's say going forward, we don't like we have this route planner, and we need to add two or three more new routes to that functionality. Instead of going through whole function, we can access only that particular route planner function, and we can add those two new routes and enhance that logic. And we can also test it independently because we know what are the inputs given to function, and we'll be knowing what are the outputs which we'll be getting from function. So this modularity is one more advantage, and the function developed can be used in other functions as well. We have to wrote one function, and if we are writing same logic in other function, instead of doing that, we can directly call this function in other function. And ease of maintenance. As I said, if you have this modularity code, at any point of time, we can add any sort of enhancements, and it will be easy to debug. If we face some error while fetching the current day of the week, instead of going through code, we can directly access that function, which will return us the day of the week. And we can debug it, why it's happening, why we are getting errors in that. So ease of maintenance. It's very easy to maintain the code which is kind of functionized or modularized. Okay. And this is our first function. Okay. Let's say this is our first function. So you might have already seen how to add two numbers, right? If you see here, this is my keyword, which will be must and should for any function definition. And this add is my function name. And I have two arguments here. Okay. Two arguments or two parameters. Both are kind of used like commonly. We can, some people will prefer arguments and some will prefer parameters, but both indicate same thing here. Okay. And A and B. So this function, this will take two numbers, which are A and B, and it will add those two numbers and assign it to one variable, which is result, and it will just return the result. Okay. This is the very simple function. So if you see here, this is the function definition. Till this return part, this is the function definition. Okay, we are defining function. We are defining function and we are asking the function to do some task over here. Okay. And after performing the task, we are returning the result, which was given by this function. And if you observe this, since we have this return value here, I am making call over here. Okay, I am just calling the function here. So we have this function name, and for calling this function name, we just need to call this function with the same name which we have defined, and we need to pass the parameters. Here we have A and B, so we need to pass two parameters, which are 7 and 9. Okay, and result will be assigned to this result variable. Now this will be storing the sum of these two, 7 plus 9. Okay. Okay, I am defining my first function, which is calculator, and it will be taking two numbers, which are A and B. Okay. And we can kind of, let's say we have, so I'm just taking these two numbers and I'm performing addition, subtraction, multiplication and division. Okay, and I am returning the result. Okay, so we have seen single value over here, right? So we can kind of return any number of values. Okay, here we are returning only result, right? If you see here, I'll be returning all these values with comma. Okay, this is my function definition. I have defined this function, and while calling the function, I have four variables here, right? First is sum, second is different, third is multi, fourth is division. Okay, and I'm just calling function, this calculator function here. Okay? And I'm passing some 20 comma 6 over here. If you observe this sum, difference, multiplication and division now, so all the values returned by this function will be stored in this variables, like in this variable sequential. If you see, first is sum, second is difference, third is multiplication, and fourth is division. Okay. So here I am returning multiple values. Okay. In the example in this slide, we have seen only single value, but we can return any number of values here. But we need to make sure that these will be kind of assigned properly. Okay. I'll explain how we can accept all those return values. So parameters are arguments. Okay. Parameters or arguments are nothing but information which we will pass to function. Okay. Let's say we are asking our child to go to shop and bring some groceries for us. So for that, we are giving him some money as well as the list of items which needs to be purchased. So in this case, our function is children. Okay. We are defining asking children to perform certain tasks, and we are giving him some information that I need this many groceries and you have to use this money for purchasing them. So he'll directly go to grocery shop, he'll purchase grocery as per the list, and he'll be bringing it back to us. So we are achieving some task over there by asking children to perform this. So this is exactly what parameters are arguments. So parameters are arguments is the information which we are passing to the function. Okay. And parameters are arguments. So which to use when? Okay. Basically, these are kind of used interchangeably. So sometimes we'll term it as parameters and sometimes as arguments. But as per the function principles, okay, functional principles, these were referred as arguments during function definition. When we are defining function definition, we'll term them as arguments. Okay. When making function call, we'll make like term them as parameters. While function call, function definition, we'll call them as arguments, and while calling the function, we'll call them as parameters. Okay, but both are exactly the same. There is no change in them. So we can pass any number of arguments. So this we have this A and B, right? We can pass n number of arguments. But ideally, since the function will be performing one single task, mostly max four arguments is the best practice. But there is no hard rule on that. There is no thumb rule or restriction. We can pass like if it demands like a few more arguments, so you can pass them comfortably. So just that we need to make sure that user should be able to understand those arguments. Okay, there is no thumb rule on number of arguments which needs to be passed, but four is always the best practice, more than like max four arguments. So the most important thing here is while making this function definition, how many arguments we have passed for this. Like in function definition, here we have two arguments, right? When we are making function call, we need to make sure we'll be passing the two arguments only. Okay, we shouldn't be passing the third argument or we shouldn't be passing one argument. So how many number of arguments we have used while defining function? We need to use same number of arguments while calling the function. Okay, you have seen here, we have A and B and I'm calling it using 7 and 9. Okay, and for arguments, okay, we have these arguments and we have one more thing which is a keyword argument. Okay, uh, let me show what it is. Okay, so for keyword argument, while calling the function, instead of directly calling argument, we'll be passing something over here. Let's say I have one more function, define print names. Okay, and just remember, never create a function which will conflict with the internal functions. We have some inbuilt functions, right? Print, input, sum. Never try creating function with that names, because that will override the built-in functionality of that particular method or function. Okay. So I have this print names and I'm having four names here, which are A, comma, B, comma, C, comma, D, right? And what I am doing here, I'm just printing A comma B comma C comma D. Right? I am not returning anything. I have any simple function which has only one line and it will just take the names and print them. Okay. And if you see here, print names of, I am giving four names. Okay. So I have given four names and I am printing them. If you see, it has printed Ram, Sita, Abhi, and Sai. Right? Let me make it some more. So if you see here, I am passing Ram, Sita, Abhi and Sai and it's printing them in same order. Ram, Sita, Abhi and Sai, right? Now, if you see this, now I am passing them with the keywords. Okay. These are the arguments which I have used during function definition. And I am explicitly assigning each value to the particular argument here. So D is equal to Ram, B is equal to Sita, C is equal to Abhi, and C is equal to Sai. So if I perform like execute this again, you can see here now Abhi was printed first, then Sita, then Sai, and then Ram. Initially, without these keyword arguments, it printed the arguments in order. With keyword argument, it's kind of a printing like whatever order we are giving these arguments, it will be printing in the same order which we have defined here. So keyword arguments are nothing but we'll be using key value pairs to define the argument name as well for passing value along with the argument name. Okay. These are the keyword arguments. So while using keyword arguments, uh, we need not to worry about order. Okay. We never worry about the order. Let's say we have taken our grocery function where we have money and items list, right? So if we are not using keyword, we need to pass money first and then items list, which will be of type list second. Okay, if you are using keyword, we can clearly define it like items list is equal to our list of items and money is equal to amount of money. So we are least bothered about the order of arguments when we are using the by using keyword arguments. Okay. If you see here, the same example which I have shown above sort of thing. So this is my function and these are my default normal arguments. I'm passing apple, car and bag and it's printing apple, car and bag, right? And in the second case, if you see, I'm passing one normal argument and two keyword arguments. We can do this as well. Okay. We can pass mix of arguments and keyword arguments as well. So you see here now it's printing apple, bat and car because these are keyword arguments and these will be printed in the same order. Okay. And one thing we need to make sure is this keyword argument should always be declared at the very end while calling function. Okay. I'm passing I'm passing Ram Sita, A is equal to Abhi and C is equal to Sai, right? Okay, okay, sorry. This will be considered as A, this will be considered as B. Okay, now let me do this. So if you see Ram Sita, Sai and Abhi, okay. So this should always follow like keyword arguments should always follow non-keyword arguments. Okay, this should always come in the last. Let's say if I try to do this, this will throw error saying that positional argument follows keyword argument. Okay. The reason being we have defined the keyword argument in between. And if I am removing this D is equal to B from here and I am assigning C is equal to Psi here. Okay. Now we'll get the previous output. Okay. Okay. Sorry. This should be D again because it will consider it in order. Like we have A, B, C, and D, right? So keyword argument should always follow the positional argument. Okay, positional argument should never come in the last. Just remember that one thing. And we have some default parameters or default arguments. Okay, while defining function, let's say we have this calculator function, which is A and B, right? We have this calculator function and if I'm making function call without passing anything, it will throw error saying that calculator missing two positional arguments A and B, right? So while defining function, if I'm not getting any value here, so I'm making it as A is going to 0 and B is going to 0. Okay. Okay. So sorry, my bad. Zero division error is invalid over here. So it will throw zero division error. If you try to divide anything by zero, it will throw the zero division error. Okay. So if you see here, when I'm passing something, like if you see here, by default, I have one and one. I have passed one. If I'm passing something to this calculator, it will calculate this. If I'm not passing anything, I have two keyword arguments over here. Okay, sorry, two default arguments. So if I'm passing anything, this will be overwritten while making function call. If I'm not passing anything, then this default value will be used. Okay. Now I'm passing some 5 comma 4 here. I'm passing some 5 comma 4 and if I check the output of this, you can see that has overwritten these arguments overwritten the default parameters, right? If I'm not passing anything, then these default parameters will be considered. Okay. For avoiding this sort of errors, if if you know any argument which you can kind of assign to some none or something, if even if it's not passed, then you can make use of this default parameters in that case. Okay. If you see here, this is the same example. I have C1, C2, and C3 is cow here, right? I have C3 is going to cow here, and I'm passing only apple and car here. But its program will print me apple, car, and cow since C3 is the default parameter. Okay. And we have this args and KW args. Okay. Args are nothing but arguments, and KW args are nothing but keyword arguments. Okay. So while defining this function, we can use this star and a double star always. Okay, star is nothing but arguments and double star is nothing but keyword arguments. So if we don't know how many values we are passing to function, okay, while defining function, we don't know how many functions. Let's say I need one function which will give me the subtract, like addition and subtraction of number of like any number of digits which I have passed. So in that case, I can't expect, right, how many users. Let's say I'm defining function with three numbers and you are trying to pass four numbers for performing addition operation, then it will throw error. So in such cases, we can use this star args and star keyword args. Okay, we just need to prefer star, like prefix star for arguments and a double star for keyword arguments. Okay, in such way, it can accept any number of arguments. If you see here, I will just given numbers and I'm printing numbers. Okay, and the result here will be sum of numbers. So on return result. And while calling function, I am passing five values here. So this will take all these five values into a tuple. Okay. All the arguments will be taken into tuple. And I am performing sum of numbers. Sum of numbers is nothing but sum over here, right? A tuple over here. So and it will calculate the sum of all these five and it will return. So you can pass any number here. Like you can pass some 10 or 20 number of arguments as well. Same with the keyword argument. So in keyword argument, we'll be kind of passing the key as well. Okay, here we are passing only positional arguments. Here you can pass like key value pair. Okay, we can assign each value to respect to key. Okay, while passing. Let's see practically this. Okay. So just make sure that all the code which is part of function should be coming in the function. Okay. And if you see here, I'm just passing nums over here and I can pass any number of values here. Okay. It will just give me the sum of that values. If you see here, all these values are stored in a tuple. If you notice, I have made print. So, and the result I have assigned it to result variable, right? If I try to print a result now, you can see some of these numbers. Okay. Same goes with keyword argument. You can assign them to some variables. A is equal to 1, B is equal to 2, C is equal to 3, D is equal to 4, and so on. Okay. And if okay, I need to pass double star. Since I am passing keyword arguments, it should be double star over here. Okay. And okay, what is the error? Is equal to 1. Sorry. You can't perform sum over here. Dot keys. The reason being, if you notice, it is being stored as key value pairs right here. Key value pairs, right? So numbers are being holded as values of dictionary. Okay. If you are passing this key value pairs, like keyword arguments, n number of keyword arguments, those will be stored in a dictionary as key value pairs. A is equal to 1, B is equal to 2. So, and I am performing sum on the values, which are 1, 2, 3, 4, and sum will be 10. Okay. So when you are not sure about how many number of arguments like which needs to be passed, then you can make use of this star and double star. Okay, and function. So function empty should never be empty. Okay, if you are defining some function, it should do something. There should be some code inside that, at least a single statement. Okay. But for some reason, if you are planning to create an empty function without which will do nothing, so we can make use of this pass statement, similar to this if and for we have, right, which will be like pass will be doing nothing. Pass will just and kind of it will do nothing if it is like passed somewhere. So we can create empty functions using this pass. Okay, and as you will see here, can return multiple values. I think in the very first program, I have shown you like a function can return any number of values. Okay. Not one value, it can return any number of values. So in the first example, I have assigned each return value to single variable. And in this case, if you see SPD, we have S is equal to 5, P is equal to 6, D is equal to 1.5. Okay. And if I am assigning it to a single function, sorry, single variable, this function is returning n number of return values, but I am assigning it to a single variable, then this will be automatically stored inside a tuple. Okay. If you are passing only single value here and calling that function and it is returning multiple values, then this will be kind of storing them as a tuple. Okay. If you see here, we have this same this one, right? Calculator one where we have this calculator, this one. And I'm taking result is equal to calculator of 8 comma 4. If you see the result now, it will be storing them as a tuple, all the four values which are returned. Okay. I'm taking result 1 comma result 2. Okay. Can you guess what happens in this case? My function is returning four values, but I am taking assigning them to two values. What will happen in this case? Any guesses? If I have a single variable, which using which I am calling function, which will return multiple values, then those will be placed in the tuple. Okay. Similarly, what happens when we have two values? Any guess? It will just throw an error for us. Okay. Saying that too many values to unpack. Okay. The function is returning four values, but we are trying to access only two values using two variables. We have two left out items, right? So it will throw error saying that too many values to unpack. So while unpacking, we should be careful. If we want to take everything into a single tuple and access it later, we can use single variable and make function call. If you are planning to access each and every return value with separate variables, then you need to define like you need to access them using same number of variables. Like how many values the function is returning, we need to use same number of values here, or else we can use single value and we can unpack it later. Okay, just make sure that there shouldn't be any difference in the variables which we are accessing through function call and the values returned by the function. Okay. And then we have local and global variables. Okay. As name suggests, local variables are local within a function. They can't come outside a function. Okay. They'll be within function. As soon as the function exists, its what you say that its scope is vanished. Okay. Coming to global is entire to program. Okay. Global variable is kind of accessible anywhere in the program, anywhere in any part of the this thing. Okay. uh, how we can see this. Okay, let's say we have this Hyderabad. Let's say Hyderabad is our city, right? Within city we have this Pukatpalli, and within Pukatpalli we have this let's say house number 5 bar 15. Okay, 5 bar 15 is a house in Kukatpalli locality. Okay, this 5 bar 15 is local to this Kukatpalli only. Okay, there might be other 5 bar 15 homes in country. Sorry, in whole Hyderabad. Those will be local to their localities. And let's say we have Charminar. Charminar is the only one landmark in whole Hyderabad. So that is global to Hyderabad city. But these house numbers are local to locality. So similarly here, a local variable is local to function. We can use it only inside function. It can't come outside of that function. Okay. And global is entire to like it's global to entire program. We can access it anywhere. Okay, anywhere. And one more thing here, we have defined one global variable, and if you are defining same local variable with the same name as global, so in that case, local variable will be taking place of that global variable. Okay, I'll explain the difference here. If you see here, I have A is equal to 7 and B is equal to 8. These are my global variables. Okay, global variables. And if you see here, I am using this global keyword. Okay. If I need to access this global variable within a function. Okay, I can use this global keyword. Global keyword here specifies that this variable is a global variable, not local to function, it is global. But I'm trying to use it in my function. And if you see here, print inside function A. Okay. If you see here, currently A value is 7, right? Initial value is 7. And we have this global A. We are telling function that this variable is global and you need to access it from global namespace. And it will give output of 7. And then I am modifying this. I am assigning A is equal to 9 for this. And now if I try to, okay, I am just assigning it. And I have this B variable as well, right? B is equal to 8. And I'm trying to print B inside the function. It will throw error saying that B is not defined. The reason being B is defined outside the function. Okay, function space. And we're trying to access it inside the function. So it will say throw error saying that B is not defined. Okay. And for accessing any global variable, you can use this syntax. Okay. Globals of variable name. If you see here, I have this global variable and I'm trying to assign it using this, right? Globals of B, variable B. It will take this variable from global or namespace and it will give me value of 8. Okay. And now B is equal to 6. I am assigning new like B is equal to 6. So now this B is outside the function. This is global and this B is inside the function. This is local to this function. Okay. This B is different from this B now. Okay. Okay. We have this B is equal to 8, right? This is global. This is defined outside the function, so it will be global to the program. We can use it anywhere. And I have some small mistake here. I'll be rectifying it while explaining the code. Okay. This is B is equal to 8. Okay, if I try to print B now, I'll get output of 8, right? Now within function, I am as making one more assignment, which is B is equal to 6. Okay. And if I'm printing it here, you can see output as 6. Okay. Now this is my function and I'm coming out of function. Outside function, I am calling this function. I'm making a function call and there are no arguments, right? So I'm just making a function call directly. And if I'm printing this now outside function, I'm printing this variable A outside this function, not inside. And you'll get value of 8 for this. The reason being, initially I have, sorry, this will be 9. Okay, I'm having these arrows are messed up over here. So outside function, okay, initially I have initialized A with 7 and within function I have made some change. Like I have reassigned A to 9. And if I'm accessing it outside, the A will be printed 9. Okay, value of 9 will be assigned to A. The reason being, I have defined A as a global variable. Okay, not as a local variable. I have made one more assignment, which is B is equal to 6. And I'm printing it within function, I'll get 6. And if I'm printing it outside function, I'll get 8. The reason being B is defined with 8 in the beginning of the program. And this B is different. This is local to the function. And I'm making change inside function. That won't affect my global namespace. Okay. I'm just copying the. So if you see here, we have this function definition, and within function we have declared a as a global variable, right? A as a global variable, and I'm kind of trying to print it inside. Okay, I have just told function consider a from the global namespace and print it, and it is printing value of 7 here, right? And then I have this print of b. So this b is not present anywhere in the function. This is present outside the function, right? And if I'm trying to make changes to that inside, or if I'm trying to access it inside, like a function like b is not present here, so it will throw error unbound local error. This unbound local error is the error which we'll be getting when we are trying to access any variable which was like never initialized. Okay, we haven't defined that variable, but we are trying to use it. So in such cases we'll be getting this unbound local variable. So let me just comment it out and print the rest of the program. If you see here, initially a is equal to a, and within function I have declared the a to be global and I'm printing it. Okay, and it will print 7, right? Then I have made assignment as a is equal to 9. I have changed the value of a to 9, and then I am trying to print b, which is global here, right? You can see that this 8 will be printed because b is equal to 8, right? And then same inside within function, I have assigned b is equal to 6, and I'm trying to print it again in the function. I'm getting 6, value of 6. So now I am out of this function. I'm not in, I am no more inside this function. And outside function, I have made function call. Function call will just execute this. Okay. If I'm not executing this function call, if you see the difference now, you can see outside function a is equal to 7, b is equal to 8. The reason being, although we have defined function, we have never called it. If we are not calling function, it won't affect our program in any way. We should call it. Only then inside function will be executed, right? So after the function is executed, this particular statement will be executed. A is equal to 9. And A is declared as a global. So it will make change to this A, which is defined in the global namespace. And you can see output as 9 here. Okay. Same. I made B is equal to 6. But if I'm printing it outside, you can see this B is equal to still 8. The reason being B is still in the global namespace. Okay. This B is local to this function, and this B is global. So this B and this B are completely different. Okay. So if I'm making this also global now, you can see I have made this also global. I told function that this B also should be taken from global namespace. And you can see now it is printing 9 here. Sorry, 6 here. The reason being we are making changes within function, but we are telling function that take global variable and make changes inside function. Okay. Just remember this global keyword and global. So these are two ways, but mostly we'll be using this global because inside function, if we are making some changes, then this global keyword help us to access the global variables. Okay. And then function within a function. Okay. We can create a function within a function. There is no restriction. We can keep on nesting a function as well. If you see here, we have this main function which is greet, and it is taking name as a input. And within that function, we have one more function which is message. And message is doing nothing. It is returning good morning. Message function is just returning good morning. And this greet function, this return is for this greet function. Okay. This return is for inner function. Okay. Now, this return will be the return for this main function. What this return is doing, it is calling this message function, and we are getting this string here. and it is concatenating the input which we are getting from this main function. And the output here will be good morning and the name which we are giving. And remember one thing, this function is accessible only from the main function. We can't use it, we can't access it from the outside functions. Okay, let me open this again now. Let me just copy this snippet. So if you see here, I have this main function as greet, and within that greet function, I have one more message, and message function is just printing good morning, and it's not expecting any arguments. But the main greet function is accepting argument, which will be name, right? If I try to print call this greet without any arguments, it will throw error saying that missing one positional argument because we are not passing any argument with the main function, right? And I am passing some name here. And you can see here, let me beautify it a bit. You can see here, I am passing Mahi as a positional argument to this greet function. Okay. And within greet function, I have this message function. And the return value of this greet function is the message function callable plus the name which I'm passing to the greet function. So if I'm calling this function here, it will execute it. It will execute directly because I'm calling this. Okay. And if I'm trying to access message from here, it will throw error saying that message is not defined. The reason being this message is local to this greet function. This is in local space. Okay. But we are trying to access it from global space, which will not happen. So this inner function will be always accessible from the main function itself. We can't access it from outside the function. Within function, we can access it. Okay. And next return function. So apart from values, so far you have seen that functions returning values. So functions can also return functions. Okay. They can return a function altogether. If you see here, same this greet and message thing. If you see here, we have this greet. Where is my highlighter? Okay. This greet is the main function. And within that, we have this message. And it is just returning me the message. Message as a function. Okay. It is returning message as a function here. And if you see here, message function, I'm just calling the greet function. Okay. And if I am calling this greet function, this will be assigned to this message function. Let me execute, will make more sense. So if you observe the code change now here, I have this greet function, right? Which is the main function. Within this main function, I have this define message, and within this function, I have this return good morning plus name. Okay. I'm just concatenating message with the name, and I am kind of just returning that, right? And if I call this a greet now, okay, now the function, since this is returning me the function, I'll be assigning it to some variable and I'm calling this, right? I need to pass a name here again. So if you see, I'm making a function call, okay, greet of Mahi, and it is returning me message as a function. Now again, I can again call this function. Since this return is a function, I can call it again here. Okay. So if you see here, while I'm calling this greet of Mahi, this is my main function and is returning me function. This is not returning a variable. This is returning me a function, and I am assigning this to message function. Now, since this is a function, I'm calling it again here, message func. Now it is giving me this good morning Mahi. Let's say I'm having one more variable here, which is I'm passing one more name here. Okay. So now I'm executing this again. So now I have this message function returned from main function, right? And if I'm executing this here again, it will say error saying that this greet is the main function. If you carefully observe this error here, greet is the main function. In the greets locals is nothing but which are local to this greet function. We have this message function within this greet locals, and this message is missing one positional argument which is name 2, right? And if I'm passing here one more name, okay, and if I'm executing it, you can see this here, right? You can see good morning Mahi and Banu. Okay, just carefully observe how I'm making this function calls. Okay, in the main function, for the first function, I'm making function call to greet. I'm passing Mahi as a argument, which will be this name. And the return value of this function is message, which is the sub function within the main function. And this is message MSG fun is this message function. And I'm again calling this message function with Banu as a argument. This Banu here is a name to argument, right? And when I'm calling this message function will be executed on as a whole. Okay. Now you can see this good morning Mahi and Banu. Okay. Not only variables. Now function as a parameter to another function. So we can also pass function as an argument to another function. Okay. Like so far we have seen only variables being passed to the function. So we can also pass function itself as an argument to other function. So now again I am will be taking the same example which is a greet function, right? This greet function it is expecting name function. Okay, this is the name function, and we are passing name function into greet function, and what the return value is hello plus name function. We are executing this name function as is, right? And the name function is just returning the name which we are passing to that. Okay. And if you see the third line, I'm calling the greet function and I'm passing this name function inside the greet function. And name function is expecting some variable here, right? Name variable, name argument. And I'm passing Mahi as the argument to this name function. And this name function is passed as an argument to this greet function, and this greet function will accept this function and it will return hello plus this name function. This name function will just return name, so I'll be getting output as hello Mahi. So if you observe, this is function being passed as a parameter. Okay, let's do this practically again. I have main function which is greet and it is expecting name function here, right? And it is just returning hello plus name func. Okay, it's name function. It is just returning a name function. Okay, and uh, and I'm having one more function which is the name function which I'm passing to the greet function. Okay, and it is returning name. It's just returning name here. Now I'm making function call to the main function and I'm passing name function. Okay. And name function here is expecting a argument which is name. And I'm passing an argument here which is Mahi. And if you see here, initially greet function will take this whole function as an argument. Okay, this whole function as an argument, and it will return hello keyword, hello word plus this name function executed. Okay. Now let's see. I'm making small change to this now. Okay. If you see here, I'm just passing this here. I have defined two functions which are greet and name func, and I'm passing this name func to the greet function, and I am concatenating with hello keyword. And if I am just passing this name function here, it is throwing error saying that can only concatenate string to string, can only perform string concatenation. But this is a function. Okay. And if I'm making function call here, you can see hello Mahesh. Just observe this thing. Okay. Here I'm passing function name. Okay. I'm just passing function name. And if I'm trying to execute the script, it throw error saying that this is a function name which we are passing. We are not passing the actual function. Okay. If we are passing function name, we should call it. Only then this will execute the both functions. If we are not passing, if we are not calling this and passing function name, it will throw error. Okay. And if I am passing this here, if you see here, I am calling function when making call to the greet function only. So if I call this now here, you can see that we are getting output. So just make sure if we are passing a function to function, we should either call it inside function or we should call it while passing in the function call, main function call. Okay. Now, recursion. Okay. Recursion is nothing but function can call itself. Okay. We have one function. We have this name function. Name function will can call itself again and again. Okay. A function can call itself again and again as many times as possible. That is recursion. Okay. We can use this when we need to use same logic repeatedly. Okay, when we are planning to use the same logic repeatedly, there will be some use cases where we might be using the same logic again and again. So in that case, we can kind of keep on calling the function iteratively. That is called recursion. So one clear caution here, like since the function is recursive, it will be keep calling itself. We need to define some particular condition. We need to clearly mention a condition when this recursion should stop. Okay. If you are not mentioning any condition, then the function will never terminate. If there is no condition, it will keep on executing n number of times, and it can keep on executing like forever, and it might crash our system by filling up all the available memory. So just make sure we'll be clearly defining the condition when the recursion should stop. Okay. So I'll explain it with an example so you'll easily understand this. Okay. Let's say we have factorial. You might have came across this factorial, right? Which is in our high school mathematics. So factorial is nothing but it will take number and it will kind of multiply all the numbers up till 1. Let's say I'm taking number 5. 5 factorial will be 5 into 4 into 3 into 2 into 1, right? So, for instance, I'm taking factorial 3. So, factorial 3 will be termed calculated as 3 into 2 into 1, right? 3 into 2 into 1. So, factorial 3 is 3 into 2 into 1. So, again, this 2 into 1 is 2 factorial. And this 1 is 1 factorial. If you see here, 3 into factorial 2, right? And then I have factorial 2 again. Factorial of 2 is equal to 2 into factorial 1, right? And I have factorial 1. Factorial 1 is nothing but 1 into factorial of 0. Factorial of 0 is 0. So factorial of 0 is 1, right? So this can be rewritten as we have this many steps here. Let's consider we have 50, number 50. We can't keep on calculating it 50 times, right? Repeatedly. 50 into 49, and again the like 50 into 1 to 49, and again 50 into 49 to we can kind of calculate this repeatedly, right? So this can be rewritten as n into factorial of n minus 1, right? Let's say n is 3, 3 into factorial of 3 minus 1, which will be 2. You see here 3 into factorial 2, and again 2 into factorial 1. 1 into 1 minus 1, 0. So at 0 will be stopping. If you see the function over here, if n is equal to 0, if you are trying to calculate 0 factorial, then 0 factorial is 1, straightforward. We don't have anything over there, right? For all other cases, return n into factorial of n minus 1. Okay. So the function, what function is doing, it is calling the function itself again and again until the condition is met. So initially we have 3 here, right? Yes, 4. It will, in the first iteration, we have this 4, and it will, what it will return is 4 into factorial of 3, right? It will return 4 into, sorry. So we have 4 into factorial of 3. And in the second iteration, again, we are passing 3 as an argument to factorial function. Not we are not passing, it is passing itself. It is calling itself with a different value. Now it is calling 3. Now now in the when it is passing 3, again it will go to this function right here, fact function. And it will come till since 3 is not equal to 0, it will come again here. We have 3. So it will return 3 into factorial of 2. Factorial of 2, right? And again, this factorial of 2 will again call this function, same function. And it will again skip this 0. And then we have 2. 2 into factorial of 1. And again, factorial of 1 call its this function again with 1 value. And it will kind of have this 1. And 1 minus 1 will become 0. Now, when we have this 0, it will enter into this loop, if loop, and it will terminate the program because we are not no more calling this, right? So if we see this practically, define factorial of n. If n is equal to 0, just return 1. Okay. In all other cases, return n into fact of n minus 1. Okay. We are returning the function, like function itself. Now, fact of 6. You can see fact of 6 is 520 because 6 into 5 into 4 into 3 into 2 into 1. This is nothing but 6 factorial, right? So what this will be doing here, in the first iteration, it will return 6 plus factorial function with value 5. And again, it will go again call the fact function. And in the second iteration, it will have 5 and it will again return fact of 4. In the third iteration, it will return 4 and fact of 3. In the fourth iteration, 3 and fact of 2. And then 2 and fact of 1. And then fact of 1 into 0. Right? It will enter. After factorial 1 is reached, it will enter into this loop and it will return 1. Now the sum will be 1. Okay. Understood, right? Recursion. Similar technique we can often, like we have seen this string reversal, right? So far we have seen this string reversal. So we can also perform this string reversal using this factorial recursion technique. Okay. If you see here, if length of s is not equal to 0, if length is not equal to 0, only then we can reverse it, right? only then we can reverse it. If length is zero, if we are not passing any string or if we are passing empty string, then there is nothing to reverse there, right? So it will just return result, okay, as same. And if length is zero, you can see here, it is doing reverse of S2 like from beginning. It is taking the very first value of S and it is returning this function. This is calling in reverse way. If you see here, reverse of Mahi, in the very first iteration, what it is doing, reverse of S of 1 is to like 1 to ending. It is just passing, calling this reverse function. It is calling itself with this string, which is from 1 to end of the string. And it is appending S of 0. Okay. In the first iteration, we have reverse function with these three passed. Okay. AHI. Because this is from 1 to end of the string, right? We have this reverse of AHI plus M. M is S of 0. In the second iteration, again, we have this AHI. From AHI, this is in 0th position now. So we'll have 0 and 1 to N is HI. HI will be again passed to the function. It will pass HI to itself and it will again execute. And when doing this HI, it will now S of 0 became H. So it will append H and it will pass I as is, right? Now we have only this one over here, right? So now this will be appended as is here, right? Okay, because S of 1 we have nothing. We have nothing in S of 1. We have only one element here. It will just be passed as is. And if I print this program, you can see how it's exactly working. Okay. A second. So if you see here, I have printed result in each and every step, right, of the recursion. You see here, initially it will return me it will start in the reverse way. Okay, you see here. Okay, first we have in the very first iteration, what it will be doing is we have this. Okay, what this is the result. Let's me return result. Got okay. This is the final result. Okay, this is the final result which we are getting. If you see here, this is the print which I have actually printed, right? And if I am assigning it to something, I will avoid the duplicate print over here. So now I have this four iterations. So in the very first iteration, recursion will start from here. Just remember, not from top, from bottom. Okay. In the very first step, we have this M over here and it is returning recursion of S of 1 to IH to the second function, right? And in the second iteration, again we have this A over here and it is taking IH. And in the third iteration, we have this IH, right? It is returning I and it will be taking uh, this will pass I as a string over to this. Okay. Since we have only one over here, one over here, we have S of 0. We don't have any S of 1. If we see this string, S is equal to A. And if I'm trying to print it, you can see nothing. S of 1 is giving nothing because the string length itself is 1. And only we can have S of 0 here. Okay. You can print A now. So this is how recursion works. Okay. In each and every step, it is taking a slice of it and it is kind of appending it with the very first letter. So it will kind of keep on going recursively. So you can have any number of things here. Okay. And if you observe this, it will just give us the return. You see here, it will keep on going. Right. It will start from here, bottom to top. Okay. You just need to read it from bottom to top. If you see here, in the first iteration, it will return this s of 0, which is m. In second iteration, okay, let me explain in this way. This will be more intuitive. Okay. In the first iteration, s of 0. Okay. This will be coming from this way. Okay. From here to here. Will come from end to beginning. End to beginning. At the end, I have this m. And for this m, and again, I am kind of appending a. And for a, again, I am kind of appending n. And then I. Okay. If you see this, this will be the first, second cycle. This will be the third cycle. And this will be the fourth cycle. Okay. So, and then where is my PowerPoint? Okay. And then this is the final slide for today's session. So these are some best practices. Okay. These are some best practices which we need to follow while defining a function. Okay. The very first thing is doc string. Doc string is nothing but we are documenting the function's task. Okay. Let's say we have this reverse string. Since we have this clear naming convention, we can understand this. But if there is someone who don't know what is string reversal, they can't understand this, right? So I am writing the description here, function description, function to reverse a string. And I'm also defining parameters. What are the parameters this function will take? It will take only one parameter, yes, and it is of type string. And this is nothing but what which needs to be reversed. And then I have returns. And returns is nothing but it is returning me res, which is the reversed version of this word s, right? This is basically a doc string. Okay. After defining a function, we need to pass all this information in the triple quotes, which are multi-line strings, right? So we need to pass all this information in triple quotes, and whenever we have this doc string, we can access it from anywhere from outside. If you see here, I'm printing reverse string is my function name. Within that, I'm having underscore underscore doc and then underscore underscore. Okay, this have some special meaning. I'll be explaining this when we are covering this classes and object oriented programming. Okay. So here I'm doing nothing. I'm just trying to print the doc string available for this reverse function, and I'll get this output. Okay. And if you are in this Jupyter notebooks, you can directly use this help of function name, and it will print the same doc string for us. Okay. And if you see this practically, I have this function reverse, right? I'm having this triple quotes for this now. And I can give anything here. Function to reverse a string. Input will be yes, which is string, and it is what that needs to be reversed. Okay. And output will be res, which is reversed string. I'm just typing some random thing. Okay. Just ignore that. Okay. It's using different indentation. Let me clarify that. So I have this reverse function now, right? If I'm typing just reverse help of reverse here, you can see this. It will print all the help which I have given to this, right? This is reverse of s, and I am having this definition, right? Function to reverse a string, what is input, what is output. So this will help new users who is using our code, and any consumers and users who is consuming our application or method. Okay, they can directly access this help part. Okay, you can even for inbuilt functions, we'll be having some nice this help thing. If you see help on inbuilt function, print in module built-ins. Okay. If you see here, print value separator, and They'll be giving all the available things here, optional arguments, file separator, and flash. Okay. This is one first thing while defining functions. Okay. Because anyone can write our Python code. These are the practices which will differentiate us from others. Okay. Because Python is relatively easy language. How we are structuring Python and whether we are not following our good practices, programming practices. That's the main impression, which will create a good impression with our recruiters or with any our supervisors. Okay, so just always make sure to write a doc string for any function which you are defining, and then we have type hinting. Okay, this type hinting this is not a kind of mandatory, but it is good to know because we are already covering this information here itself, right? Let's say if they don't have interest in going through docstring and they need to understand what are all the types of input and return. In such case, these type hints are useful. Okay, if you see here, this is my function definition, and I have given this colon and data type. This indicates this S argument is of string type. I need to pass string always here for this S. And for this return value of this will always be a string. Okay. This will always be a string, this return type. Okay. And then naming convention. So how we'll be naming our functions? Okay. As per PEP8, we have this PEP8, which has defined some set of principles for programming in Python. So as per PEP8 standards, each function should contain only lowercase letters. Okay, lowercase letters, and we can use separators in between. If you see this reverse string, I have used lowercase and I have some separator over here, which is underscore, right? So I can use the function name should be descriptive. By looking at the function name, one should understand at high level what the function is able to do. Okay, function name shouldn't be kind of confusing. Function name should be self-explanatory. There is no restriction on length of the name, but we need to keep it short and clear with lowercase letters followed by like separated by underscore. Okay. There are few cases where we can use function name, like we can include capital letters as well. Like we can use capital cases in function as well. But we are following some conventions which are already in place, like when employing this threading and parallelism techniques. So they have followed this convention where they are using like reverse string. Okay, they're using such like capital words. Okay, reverse string instead of separator. So if you have already such rules in place, you can go with the same convention. If you don't have any such convention, always try to follow this lowercase with underscore separator. Okay, I here only I can have this type hinting. I have yes, and this will be a type string, and return also will be string. Okay. And if you see here, I am calling this function now reverse. See, I did nothing here. Okay, I did nothing. If you see here, this is just hinting me. You need to pass a string. Okay, you need to pass a string for this function, and return value also will be string. Okay, only concerned with data types. If I'm passing some other data type also here, it won't affect anyway, because this is we are just hinting others that this function is accepting string and returning string. It won't impact our functionality. You can pass integers or this thing, but this will kind of misguide the person who is reading our code. Okay, should always make sure we'll be returning and accepting only this which were defined in docstring or in the type hinting. Okay, these are some good best practices with functions. Okay. So I think this is all regarding functions, and even though functions looks very simple, like while actually working on some real world projects or some lengthy codes, you'll realize the power of these functions. Okay. So I think that's it for today, guys. If you have any questions or queries, or if you need me to revisit any topics, just let me know so that I can revisit them.